1, 2, and 3 ask you to find the end behavior and the y-intercept. Remember that end behavior is like high, high, low, 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 high, high, low, and then the y-intercept is where x is 0. So if I'm finding the end behavior, I'm looking at the highest degree term. This one is odd and positive. Odd means they're going to be opposites on the two ends, either high, low, or low, high. And positive means it's ending high. So this one's going to be low, high, low, high. And then my y-intercept, I'm making all the x's 0. So 0, minus 0, minus 0, plus 1. Y-intercept would be 1. Does that sound familiar to everyone? And again, you can go back, check your notes for the whole high, high, low, low, all those good things. For number 3, I'm going to have 2 times x times x times x times x. 2x to the 4th. Why did I count this one twice? Because it's squared. So 2x to the 4th, that's even and positive. So even, they're going to be the same. Positive, they're going to end high. So this one's going to be high, high. But then when I make x 0, I end up with 2 times 0 minus 3 times 0 plus 2 squared times 0 minus 5. If I multiply this all out, 2 times negative 3 times 2 times 2 times negative 5. Go ahead and do that with a calculator real fast and tell me what you get. Is it negative 120? I think it ends up being positive 120. So your y-intercepts can be way off the graph, but again, we're just finding where it is. Is everybody okay with end behavior and y-intercept? So typically you do those two and you find the roots or the x-intercepts, and that requires factoring. There are 3 main ways on these next few where you're going to factor and solve. If you have 4 terms and they don't give you any more information, you're probably going to use factoring by grouping. So that looks like number 4 and number 8 are going to be factoring by grouping. If there are 3 terms, then you're probably going to do either GCF and or that polynomial format of x squared and something and x squared and something. Right? Kind of like x and x factoring like normal, but with x squareds. So you might do one or both of those. So that looks like 5, 6, and 7. Those 3 are going to be similar, 5, 6, and 7. And then 9 and 10, if they give you a factor or a root, you're going to be using long division or synthetic division. So long or synthetic division. So real fast, I'm going to show you an example of each of those, at least starting it. I may not finish it, because we were just practicing in Unit 2 review how to finish factoring. But real fast here, factoring by grouping. For number 4, I look at the first 2 terms and decide that they both have a 4 and an x squared in common. So I can take a 4x squared out, and I'd be left with an x and a 5. Whereas these 2 look like they have a negative 9 in common, leaving me with an x and a 5. So, since both of them have an x plus 5, I factor that out. And I take what was multiplied by both of those in its own set of parentheses, 4x squared minus 9. 4x squared minus 9. This one's a difference of squares. It factors again. So the x plus 5 is here. This would get me a 2x minus 3 and a 2x plus 3. That's fully factored. I could set each of those equal to 0 and solve and get all of my roots or x-intercepts. If it's a real number, it doesn't have an I, it's an x-intercept. If it has an I, it's just a root, not an x-intercept. So this one, I would have 3 x-intercepts, negative 5, positive 3 over 2, negative 3 over 2, which is 3 x-intercepts. Number 5, factoring by GCF, looks like they all have an x, so I would take that out, left with x to the 4th, plus 48x squared, minus 49. This then, that x to the 4th, tells me I'm going to have an x squared and another x squared, and negative 49 multiplying to negative 49, adding to 48 sounds like a plus 49 and a minus 1. And then I need to check these. Do they factor anymore? This one does. It's a difference of squares, x plus 1, x minus 1. This one does not factor, x squared plus 49. 3 of these are going to give me zeros, or x-intercepts. 0, negative 1, positive 1. This one, I'm going to have to solve. I'm going to set x squared plus 49 equal to 0. I'm going to get 2 imaginary answers. So this one has 3 x-intercepts, which we found, but you need to find those last 2 roots that are imaginary. And then the last one I want to show you here, number 9, I'm going to show you synthetic division. If you want to see long division, you can ask. Synthetic division, take the root here from this one, so 7. 7 goes in a little box. Take the coefficients, 1, negative 12, 41, negative 42. Bring the first one down. 1 times 7 is 7. Negative 12 plus 7 is negative 5. Negative 5 plus 7 is negative 35. 41 minus 35 is 6. 6 times 7 is 42. 0, as it has to be. These 3 then are my coefficients. X squared minus 5x plus 6. Don't forget that this is still multiplied by that x minus 7 that we factored out. This then factors again. X minus 3, x minus 2. So I end up with a positive 7, a positive 3, and a positive 2 would be my 3 x-intercepts. So those are the 3 types. I want you to do 2, 6, 7, 8, and 10 for homework there. Tomorrow, for you guys, Thursday, we'll go over any questions on this. We might take a little bit of a look at the back side as well to get you started. And then again, the hour and a half after that will be time for you to finish this, time for you to retake a test, time for you to take a missing test to get caught up before we are out of time.